All right, we are in section 4.3, and we're going to be graphing proportional relationships. Now, before I pop up the key idea, I'm going to tell you this. It's about direct variation, and we just got done doing that from the 7th grade book. But direct variation has more than just y equals kx. So I'm going to show you how we're now going to relate slope and direct variation and put it together. All right, so here we go. You know that y equals kx is direct variation, where k, this is important, is the constant of proportionality. Well, now we're going to start talking about slope, and here's what it means. When two quantities, x and y, are proportional, please let's think about this. They're proportional, which means any value of x and y. For example, let's say x and y, we have 2, 4, and 8, 16. These are proportional because you could write them, for example, you could say 4 is related to 2, which is 16 is related to 8. That proportion is a true statement. If you cross-multiplied, you would get 32 equals 32. Therefore, these two ordered pairs are proportional. So the relationship can be represented by the direct variation y equals mx, where m is the constant of proportionality. You'll notice once again that it must go through 0, 0. And the graph of y equals mx is a line with a slope of m, wherever 1 is, because this is the change in y divided by the change in x. So if the change in x is 1, m is your slope. So, and it passes through the origin. Example 1, graphing a proportional relationship. So here we have a graph with an internet plan, talking about the cost versus data used in gigabytes. So the cost y in dollars for x gigabytes of data on an internet plan is represented by the equation y equals 10x. Graph the equation and interpret the slope. Now, as you can see here, I've already graphed it for you. And I want to make note of this graph. When you graph, you must be specific. You're going to label x and y as data used in gigabytes and cost in dollars. You will notice that the line does not go through 0, 0 because we can't have negative data used. So therefore, the x value must remain positive. So we must interpret the slope, and this is what I love. I love, 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 love this. You will notice that right here, 110, this is 1, and it goes through 0, 0, so 10 is your slope. So m, and by the way, this is also your slope, m is 10. So you must determine what 10 means. So, here's where I go with this. You know slope is change in y over change in x. What is your y label? Well, your y label is dollars. What's your x label? Data used in gigabytes. So this is gigabytes. So what does the 10 mean? Well, the 10 would mean that it costs for the internet $10 per gigabyte. And that would be your answer. Now in example 2, we're going to write and use direct variation within an equation. So here's what it says. The weight y of an object on Titan, one of Saturn's moons, is proportional to the weight x of the object on Earth. An object that weighs 105 pounds on Earth weighs 15 pounds on Titan. Write an equation that represents the situation. So this is where we got to think what we're going to do. So how are you going to do this? Now we have a couple options. So y is Titan and x is Earth. So I'm going to write this down. X, y. This is Earth. This is Titan. Or ET. That's kind of funny. So an object that weighs 105 pounds on Earth, so that could be 105, would weigh 15 pounds. So I have, right here, an ordered pair. I want to find the slope. So here's what we got to look at. Our equation is y equals mx. Now remember, we've also done y equals kx. And how did you always find k? You divided y divided by x. The constant of proportionality is taking y divided by x. So here I could plug in my y and my x. And if I want to find m, I divide both sides by 105. And m would equal 15 over 105. But if you simplify that, it would give you 1/7. But here's the most important part. I have to then take that m and plug it in. And that gives me y equals 1/7 x. That's my answer in direct variation form. Y equals 1/7 x. Now you don't have to go through all this process if you know that you just have to divide y divided by x. Y divided by x. Y divided by x. Y divided by x. Don't ever forget y divided by x. So my equation is y equals 1/7 x. Now it says, how much would a chunk of ice that weighs 3.5 pounds on Titan weigh on Earth? Well, we know Titan is y. So 3.5 has to be y. So we do 3.5. We plug it into our equation. So the opposite of timesing, I don't like timesing. The opposite of multiplying by 1/7 is dividing by 1/7 or by multiplying by the reciprocal, which is just 7. And so x, 7 times 3.5, 7 multiplied by 3.5 would be 24.5. So what's your answer? The answer would be 24.5 pounds. Where? On Earth. Make sure we always label. So in example 3, comparing proportional relationships. The distance y in meters that a 4-person ski lift travels in x seconds is represented by the equation y equals 2.5x. The graph shows the distance that a 2-person ski lift travels. So right here we can see on the left a 2-person ski lift. Which ski lift is faster? Now, we don't have a graph for the 4-person, but we do know a 4-person ski lift has the equation y equals 2.5x. Well, that means the slope is 2.5. What does that mean? That means we go 2.5, look at our labels, y divided by x. This is 2.5 meters per second. So this is the 4-person ski lift. Now the 2-person ski lift, I can find the slope. M equals, and all I have to do is find the change in y divided by the change in x. So I could take 12 minus 4, which is 8, and 6 minus 2, which is 4, and that gives me 2. So that means this is 2 meters per second. So which one is faster? The 4-person lift is faster. Part B says we have to graph that equation. Now if we graph this, notice I label, and then it says graph the equation that represents the 4-person lift in the same coordinate plane as the 2-person lift. So you would actually have to graph it together. Notice that the 4-person lift is steeper. So compare the steepness of the graphs. Well, that's pretty easy because which one's steeper? Well, the 4-person lift is steeper because it's faster. So the most important part, though, is what does it mean in the context of the problem? Well, in the context of the problem, if we know it's steeper, we know this. The graph that represents the 4-person lift is steeper than the graph that represents the 2-person lift. So what does it mean? It means the 4-person lift is faster. By how much? You could say it goes an extra 0.5 meter per second.